Algebra 1, Concept 27a, Solve easy systems by substitution. When is graphing to solve a system of linear equations not a good idea? Well, consider this system on the screen. We have y equals 2x minus 3 and y plus 4x equals 18. Can you determine the solution from the graph? Well, the solution is the point that the lines share. We call that a point of intersection. If you look at this point, it's difficult to determine exactly what the coordinates for the point are. Perhaps it's 3.5, 4, I can't even tell exactly. But again, we're not sure. So graphing is not the best way to solve this to get an accurate solution. To get a more accurate solution, we can solve the linear system by an algebraic method called substitution. Just a reminder, a linear system is two or more linear equations with the same variables. So that means that both of your equations will have an x and a y, or an a and a b, an input and an output. And then the solution of that system is a point, or sometimes it's more than one point, that makes both equations true. We can solve by graphing, and the point that makes both of them true is the point or points of intersection. Now we're going to learn how to solve algebraically, and this video will show you how to solve using substitution. To begin, you want to get at least one of your equations into a form where you can substitute. So you make sure that one equation is solved for a single variable. So if we look at our two equations in this system, we have y equals 2x minus 3 and y plus 4x equals 18. Well, our first equation is solved for y, so that makes it good to substitute. So now we're going to substitute what y equals into our other equation. So y equals 2x minus 3, and I'm going to substitute it into my second equation. So instead of y, I simply write 2x minus 3, and then I finish the equation that I'm substituting into. If you notice, now we just have a one variable equation that we can solve. So I'm going to combine my x's. I have 2x and 4x, which will give me 6x, and then I'll bring down my minus 3. I want to move my numbers over to the other side, so I'll add 3 to the other side. So I'll have 6x equals 21, and then I'll divide by 6. And x will equal 3.5. So I can either write this as a mixed number or as a decimal. Now, once you have solved for that first variable, we need to find the other variable in the pair. So we're going to take what x is and plug it into either one of our originals. I'm going to put it into the first original equation because it is the easiest form to plug it into. So I'm substituting in 3.5 for x. 2 times 3.5 is 7. 7 minus 3 is 4. So now I'm going to write this as an ordered pair. So my solution, which is my point of intersection of these two lines, is 3.5, 4. Let's look at the next example. So we're going to solve this linear system. We have the line y equals 3x plus 2 and the line x plus 2y equals 11. So I'm going to do my first step and make sure that one of my equations is solved for one of my variables. If it's not, I'm going to have to do that solving. But this one is. So now I'm going to take what what y equals, which is 3x plus 2, and I'm going to substitute it into my second equation. When I substitute it, it's 2 times everything that y equals. So I open up a parentheses so I can put in that entire expression. And then I just finish my equation. So I say equals 11. Now I have a one variable equation, and I'm just going to do the math. So I'm going to distribute my 2. Then on the left side, I'm going to combine my like terms. So I have x and 6x, which is 7x. Now I'm going to move my number over. So I have 7x equals 7. Divide both sides by 7. So my x-coordinate is 1. Now to find the y-coordinate, I go to one of the original equations. I'm just going to choose the one that's solved for y, and I'm going to substitute that value for x into my equation. So 3 plus 2 is 5. So my solution is the point 1, 5, and I will write that up here. And that is my point of intersection. All right, let's work a third example together. So we're going to solve the linear system y equals 6x and y equals 5x plus 7. So both of my equations are solved for y. I'm just going to choose the first one and take the value for y, and I'm going to substitute it into the second one. There. So I'll have 6x equals 5x plus 7. Now I'll subtract 5x from both sides. So that is x equals 7. I can choose either equation to substitute my value for x in, and I'm just going to choose the first one. So 6 times 7 is 42. So my point of intersection, which is the solution of this system, is the point 742. Now, when you are solving a solution, you can always check your answer. So you just go back to the original equations and you plug in your values for x and y. So I'll do that in red. So I'm going to plug in 42 for y into my first equation, and then that is going to equal, hopefully, that will equal 6 times my x value. Well, you can see that this is true, that 42 does equal 42. So my solution checks in my first equation. Now I'll try it in my second. So I'll plug in 42 for y, and then I need to take 5 times 7, and I'll plug that in here in a minute, and then I'm going to add 7. Alright, so on the left I just bring down 42, and here I have 35 plus 7, which does equal 42. So you can always check your solution. You just plug it into both equations and make sure that you have 2 true statements. So now what you need to do is the independent practice problem. Pause the video, do the problem on your own, and then come back to this video to check your solution. All right, I'm going to step you through this solution. So look at your second equation. Hopefully you notice that it was solved for y. So you're going to take that and plug it in to the first equation. Now you need to make sure that you had opened a parentheses and then plugged in the value of y. And then you have that one variable equation that you can solve. Give us 51. And then combine your x's, so we'll get 12x plus 51 equals 3. Subtract your 51 from both sides, so 12x equals negative 48, and then divide by 12. So x equals negative 4. And now I'm going to pick one of my original equations, and I like the second one, which is y equals negative 5x minus 17. And then I'm going to plug in negative 4. So that will equal positive 20 minus 17, or positive 3. So our solution is negative 4, positive 3. There is no teacher talk after this video. Now you should do the practice over Concept 27A in Math Excel.